So what I'm going to do in this video is an applied exercise with decision trees. I'm going to fit a model to a data set, and then I'll evaluate it using a validation set approach. So the first thing, let me just tell you what I have up right here, which is I just have Jupyter Lab up here. I have one line here for a module that'll auto-format my code, but that's not really doing anything. That's just a convenience so I don't have to do formatting manually. The other thing I have up here is the SciKit-Learn documentation. And there's a really useful part of the SciKit-Learn documentation in order to play around with models, which is that it includes data sets. The data set I want to use is the wine data set. And what this wine data set has is it has 13 features, which are all real positive numbers, so they're numeric features. That's not to say trees can't be used on categorical features or even ordinal features, but this will just make it easy for the demonstration. I have 3 classes. These 3 classes are 3 different types of grapes. Unfortunately, they're not labeled what grape is what. I think these may have been experimental cultivars. Either way, here is the data set. And one other thing worth pointing out is that there are 3 classes. These 3 classes have decent balance. There's no huge imbalance in this data set. Okay, so let me go ahead and get this wine data set in. To get this wine data set in, I'm going to do bunch, and this is because this is a scikit-learn bunch, and then load in the wine. Now, for load wine to work, I'm going to have the function imported. Now, I'm going to do one more thing that just makes it easier for us, which is I'm going to read it in as a data frame. And what bunch will end up being is a dictionary-like object called a scikit-learn bunch. The important part of the bunch is bunch.frame is going to give me a data frame. And this will have both my targets and my features in it. So target is called target, labeled 0 to 2 for each of the 3 wine cultivars. Everything else here is the features. Now there's 2 other useful parts that the data set's going to have in it, that the bunch is going to have in it, and those are the feature names, not brunch, bunch. And we also have the target names. And I'm going to use these later in order to make my visualization of a tree that I'm eventually going to build look a little bit better. So now I got my data set. And let me go ahead and separate it into an X matrix, a feature matrix, and targets Y. So to get the targets, I'll take the data frame, to get the features, I'll take the data frame, I'll drop the target, and I'll do values to convert it to a NumPy array. So this will be my X matrix. Then my Y, my targets, are just going to be the target. And likewise, I'll convert that to a NumPy array by doing values. So I have X, a matrix, and I have Y, a vector of the targets. So at this point, I'm going to set up my test and train set. Scikit-learn has a built-in function for this called train test split. And it will return 4 things based on being fed an X and Y matrix. I'm going to have a default split size, and because I want to prove a point later, I'm not going to define the seed, so it will actually be a different random split every time I run the code. And by default, it looks like the test size is 25% of the data. The train is the other 75% of the data. Oh, and of course, to use this function, I'll have to import. And now my data is prepared. So like every model in scikit-learn, the interface for a decision tree classifier is the same as any other classifier, which is that it has some parameters I can set, and it has a fit method, and it also has a predict method. So let's go ahead and implement a decision tree real quick. So I'll need to import the decision tree. Let's go ahead and instantiate one. CLF for classifier equals decision tree classifier, and I'm going to accept all the defaults for this demonstration. To fit the model, I'll simply fit it on the training data. The train set, so X train, and the targets Y train, and this will fit the model. At which point, let me get predicted values for the model on the test set, CLF.predict, and I'll stick in the X matrix, the feature matrix for the test data, and this will get me Y test predicted. This will get me my predictions for Y test. In order to see how well we've done, let's use the classification report. But before we use it, we'll have to import it. And classification report takes the truth, which is Y test, and it also takes the predictions, which is Y test predicted, and it will give me a report on how good of a job the model did. So right now it's telling me that the model has 84% accuracy for this particular train test split. That's basically it for training a tree and also evaluating it, just like any model in scikit-learn. But let's look at a few things we can do with trees in particular.